Hello, people that are gone. I kind of forgot to tape, so I'm going to go ahead and quickly scroll through the answers. Pause as you come to them so that you can check them as you go. There's 4, 6, 14. There's 16 and 20. 32, 46. 54, 76. And done. Okay, now we're going over just a few questions from homework. Here we go. All right, number 17 says basically use properties to simplify. So what are we simplifying? Oh, that's it? Okay. So he's one that's just tricky. He's not like he's long, he's just tricky. Okay, someone tell me something they thought of doing with properties. I see a division. Cassette, what'd you think to do?
Oh, wait.
Okay, so then Luke, you were saying subtract because I can say, well, logarithms of a division of a quotient. I can make it log base 5 of 1 minus log base 5 of 250, right? Is that okay? What's any log of 1? Oh, I don't know that. I don't remember. Stop. You are more capable than you think you are. Ready? If you don't know him, make him his own little problem and say, who are you, log base 5 of 1? Make it unknown. And say, base to the power. If you don't like that, say whatever. The only way to undo a logarithm is to, there we go, 1 equals 5 to the x. What power of 5 makes 1?
0.
Only 0. So then you can say x equals 0, so then you can go back and say, who's this whole guy? 0 minus, now, not that you have to show all that, but that's the process. If you don't have these memorized, you frequently forget them. You understand the process. Say 5 to the who is 1. Oh, 5 to the 0 is 1. Now, over here we have log base 5 of 250. Oh, I really wish we could get that 250 into, oh, how many 5s go into 250? Let's check them out. 5 goes in how many times? 50. 5 goes in how many times? 10. 5 goes in how many times? 2. Oh, there's a 2. Well, he's in my way. Well, what can we do? Couldn't we make it log base 5 of 5 cubed times 2? Right? 5 cubed times 2. Now what can I do now that there's a times?
Just split.
Split it up and say, oh, hey, now I can make it negative log base 5 of 5 cubed plus log base 5 of 2. What happens to this little dude over here? Kind of cancels, but do you know what's left? Log base 5 of 5 undoes each other. You have a 3 left. Is there another way of thinking about that with a property? The 3 is a power, right, so it can pop down, and then when I bring the 3 down, I have log base 5 of 5, which cancels away to 1. So I can add that little negative. I'm going to put the negative 3 in here. Minus log base 5 of 2. Is that going to do much else? Does that seem to match what it's supposed to?
Another one.
I mean, we could, but since 2 isn't a square root of 5, isn't a power of 5, it's just going to be a messy answer anyway. So I'm assuming we've gone as far as we can. Did anybody write down the answer? Does that match? So the problem is, this would just be a decimal at this point. And so if it's a decimal, it's kind of like it's better to leave it in this form, like square root of 3. We just would rather have square root 3 than the nasty decimal of 1 point. Something. Does that make sense? Dun, 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 dun. 17, good. A little tricky. Then we're going to number 54?
Yes.
Okay. No. Number 54, what were the directions first? Expand. All right, so what was the thing we were expanding? Log base?
2, 1, 2x, 4, and square root of y over z cubed.
Ooh, square roots over everybody? Okay. For this one, you have to keep it legal. Because there's a lot of illegal stuff you might try. Have to keep it legal or else this, and it's gonna become a mess. Question. As you read this problem, what is the big operation going on between two pieces? Multiplication. X to the fourth times this nasty square root thing. So couldn't I right away break him up to be log base 2 of x to the fourth plus log base 2 of, interesting, I wonder why I'm rewriting him. Log base 2 of x to the fourth plus log base 2 because of the times. I rewrote the square root as a 1/2 power because what's cool with him? And powers. I can put it to the front. Now, there are 2 ways to go. One way is I can bring the 1/2 to the front. Technically in this one, square roots of fractions, I could have made it instead square root top, square root bottom, so I could bring this little 1/2 into both of the guys. But as it's written, I'm just going to go ahead and bring that 1/2 down. I have log base 2 of y over z cubed. We'll get back to him in a second. And can't I also bring the 4 down? Okay, am I done?
You have to take out the powers in order to.
Well, I could have either, Luca, I could have brought the 1/2 in, y to the 1/2 and z to the 3/2. I could have done that. I just saw a big power that I just brought down to not have to worry about. But you could have done it either way. But when it says expand, what it wants is the simplest argument. So x to the fourth isn't as simple as x. So they want you to bring powers down if possible. Now, I'm not done because don't you guys still see a division? Okay. So what do I do with division? Log base 2 of y minus, can I just be super cool and bring down the 3 as I'm writing the log base 2 of z? Right? Z cubed, bring down the 3. But what do I have to remember is going on with this entire dude? It's in parentheses with a 1/2. So either way you do it, the 1/2's going to end up, look at going to both. It either goes to both here and then it comes down, or it goes to both once you bring it in. So then I have my 4 log base 2 of x, and to finish off, they probably don't like the little 1/2 with the distributing, so they just bring them in. Or I should say with the parentheses. Does that make sense? And we have Unamas, right? Number 57. Any questions on the steps though? How I got that legal? Okay. Last one. Have your composition books close, okay? Number 57. Good news is if you look at the backboard, we're only starting section 3-4 today. So homework is to start section 3-4. Can lead a horse to water. Okay, number 57. What's the question? Condense? Expand. So we're expanding again. What's my expression that we're trying to expand? X to the third.
You multiply that by parentheses x squared plus 3. And that's under.
Under?
Yeah, like that's inside of like 4. I don't know, it's kind of weird.
The fourth root?
Yeah, 4 through. That's kind of.
Oh, like that.
Yeah.
Is there anything else?
No.
You're like, anything else, that's enough. Okay, just checking. I'm running my own. Okay, that's in there. Anyway, what's the big thing going on? The entire argument is in fourth root, right? Okay, all right, cool kids, we got this. How do I rewrite a fourth root, and why am I putting parentheses? Could I use brackets and be all squiggly? I guess. I just use big old parentheses. I have 2 options. I I can bring the 1/4 down and have to distribute him later like you just saw, or I could bring the 1/4 in because it's a power. And I have multiplication. Which one would you rather? Both are fine. Bring him down
Yeah.
or put him in?
Bring it down.
Okay. So let's bring him down. And to be honest, that's the one that's safest. Because if you get used to bringing them in, you might accidentally do this one day, bring him into both of those, and that's killing a puppy. So it's a little dangerous. You can bring him into each factor, but you can't bring him into the sum. That's illegal. So we'll just bring him down in front. And then we have x cubed times, right? X squared plus 3. Well, what can I do with that times? Make it the sum of 2, right? And I can be super cool and I can write that x and say, hey, the 3 is going to come down for him, and then, he doesn't have a power to come down, but what can I not forget? Now, this bit they use brackets, but parentheses would have been fine. That 1/4 is still a chillin'. So now I bring that 1/4 in and I say, okay, I have 3/4 ln of x plus 1/4 ln of x squared plus 3. Just a couple of you would say, yay, let's split them up. There's no property for this sum in an argument. Let's bring the 2 down. No, the whole thing needs to be squared. So guess what? Done to one side. All right, let's open. Here we go. Let's start 3/4. So as you guys are getting your notes out and ready, this was the last example we didn't get to look at yesterday. It was just a homework help. I'm just wondering, after your wealth of experience in homework last night, could you guys tell me what this equals without a calculator? You did subtract, right? ln 1 minus ln e to the 1/2, then what? ln 1 minus 1/2 ln e. ln e, log base e is e, is just 1. ln of 1, anything, any logarithm of 1 is 0. Now hold on. How could I have done that straight to negative 1/2 without showing, with showing only one step? I could do this exact same thing in one step. You guys do a great job. But you did 1, 2, 3, 4, kind of 5 steps. We'll say 4 steps. No. Without the calculator, how could I have done this in one step? Do you want me to show you one more example and give you the one step answer and then see if it makes sense? Okay, so I thought to give you something like log base 7 of 2 over what if I was to say, hey, no big deal, that's negative 1/3. How'd I get that? And no, I didn't do 5 steps in my head. 4 steps in my head.
Whoa.
No, not in the denominator and numerator.
You're doing.
Nicole, what do you see?
You put 1/3 and then log 7 to 7, and that's minus log 1, and that's just 0.
Kind of, but
I see.
you're going through all the steps. I'm not saying you're wrong. You're going through all the
I
steps,
see
and that's
1
good.
and 3, 1 and 2. I don't get why. Oh, and they're negative because
What's negative?
it means but
No, what's negative in there? I don't see a negative. Do you see a negative? I mean, I see a
I see a
negative, but do you see a
negative in the square root. But the
Where's the negative though? He's a positive 7. Where'd the negative come from?
Oh, from the division.
From the division. What gets turned negative when it's in division? Or the denominator?
Oh, there's
What gets changed into a negative because it's in the denominator?
Numerator.
I wanted to say it.
How can you rewrite him with negative exponents?
Oh, negative, square root, no.
Cubic
Log
root.
of 1.
There you go.
Dun, 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 dun.
Ah.
Because it's to the 1/3 and it's in the denominator, which we can write as a negative 1/3 power because it's down in the denominator, and I can say, okay, yeah, that just cancels negative 1/3.
See, I'm sorry. Are we getting the answers from like
To play it safe.
1?
I can say this good.
Is it?
Huh.
Alright, the, like the 1 over the power in the bottom? Because that was the answer both times. Like,
The roots
one-
are important, right? That's how I get the 1/2 and the 1/3.
He's saying that like it's a square root with the 2 and then 1 on.
Oh, no, it's not from
And then
this.
the cube root.
It's not from this.
Oh,
If I was to do one more,
it's just
and I was to do ln of 2 over the 4th root of e cubed, the best I could do, the best I
would
could
say
do
one
is
half.
ln of 2. Technically, I guess, if I was to write it properly, it'd be negative 3/4 plus ln 2.
oh,
I would have to do ln of 2 minus ln of this,
oh, this is gonna be
or I could make it ln of 2 times
Gonna be
e to the
ln.
negative 3/4, but this is separate. Does that make sense?
yeah.
So he's his own little dude, and then he's his own little dude.
Okay.
Does that make sense? All right, we digress. I mean, we don't, 'cause it's on topic, but it's not. Here we go, 3.4. Number 1, you know we're taking 2 days on this, and that's not just because we took forever on homework questions. Number 2, we're taking 2 days on this because, putting it all together.
Oh, no.
Look at the title. Section 3.1 was exponential. Section 3.2 was like intro to logarithmic. Section 3.3 was like, hey, more logarithmic. And section 3.4 is like everybody. And not just everybody, but exponential and logarithmic what? Ooh, equations. And guess what? They can't just be solved with the 1-to-1 property. Oh. They can't just be solved with the 1-to-1 property. Now, one more thing I feel like it's my duty to remind you. Chapter 1 had 10 sections, Chapter 2 had 7 sections, Chapter 3 has 5 sections.
Dang it. Do the sections just keep
Not necessarily. For the first 3 chapters, yeah.
So does that mean the test is next week?
Friday? Wait, next week, what?
So we're doing 4 today, we're doing 4 on Monday, we're doing 5 on Tuesday, and maybe 5 on Wednesday, it depends. I think we could just do Tuesday and have a test on Thursday.
What's on the Friday?
No, definitely
Friday
not.
sounds better? On Thursday? Okay, we'll have a test on Friday. So plan ahead, Friday, okay? So far, what have we seen about solving stuff? 1-to-1 properties, and they were nice. Inverse properties, and they were kind of complicated, but kind of nice. But section 3.4 says you need a little bit more. Not more as in you need more information. You have enough, but you need to see how to face harder problems. You need to see how to face harder problems. Excuse me. Don't know where that.
What'd you say? How bless you, your family.
It was very formal. Alright, so what else do we need besides the 1-to-1 properties and the inverse properties? Well, let's just start seeing examples and see how far we can get with what we know. Sound good? Those of you that are still writing, all right. I see your frustrated looks. Here we go. Dun, dun, dun. Okay, thank you. Welcome. Let's see how far we can go. Here, let's do this. That's not gonna work. That's better. Let's see how big I can make them. Oh, that's better, right? Okay. Letter A. How do we solve? 2 to the x equals 32. We've done this one.
You do the 32, you make it 2 to the 5th.
Right?
Yeah.
Because 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. Okay, or you can do the little boxing, little tree thing. So this one, what do I need to... What do I need to solve? What property? 1 to 1. That was easy cheesy stuff, right? Okay, letter B. How do I solve? Oh, don't just cross it out. Technically, to be legal, what would I have to do first? To be legal.
Combine.
No. Well, okay, that would work too. But you could just add to the other side and say, hey, it's 1 to 1 property. X equals 3. Now, hold on. Why was Karina saying combine them? What could we do with subtraction? We could divide. So the alternate could be ln of x over 3 equals 0. Uh-oh. I need to undo the ln. Who undoes an ln? E. E to the ln is just x over 3, and x over 3 equals?
1.
E to the 0 is 1. Hey, what's x equal? Both ways work. 2 alternate ways, 2 alternate directions, but both completely legal. Okay, how about letter C? Huh. What do you think, what base do you think is in common between 1/3 and 9?
3.
They both have stuff to do with 3's, right? So 9 can be 3 squared. Struggle. What can 1/3 be? 3 to the -1. Nice. So I can make it 3 to the negative x power to a power you multiply equals 3 to the 2, and negative x equals 2. So x equals -2. 1 to 1 property, but it was a little harder because we had to do a negative exponent to make things easier. Letter D. Wait, focus. How do we make 7 an E? Or how do we make E a 7? How do you undo an E? So we're getting to stuff where we have to put in ln's if there's not an ln, or we have to put in an E if there's not an E. But what happens to ln of E? Cancels. You get an x, or if you think about it, put the x down, and ln of E is 1. Equals, oh hey look guys, I'm done. I'm done. It's ugly, but it's right. Done. Okay. Is that okay? Sean's missing it today. Letter F. And Ellen and Harris. Hi guys. Okay, F.
Hi, Sean.
Guys, what do I do on F?
I'll do a 10. 10 to the -1.
Oh, 10 to the, because common log has a base of who, even though he's not there? He has a base of 10, so I need a big old 10 to the, and a big old 10 to the, and what happens over here? Right? The 10 to the power of in the log, okay, either be writing or be super focused, my chatterboxes. 10 to the -1, who's that?
1 over 10.
Nice, so I would write it in a little bit better form, 1 over 10. Done, done, done. G. 2 ways. And technically you could have used the 2 ways on him or him. One way is to memorize how to go from logarithmic form to exponential form and say, oh, that's right. Base to power equals. That's one way. Or what's the other way I've shown you how to undo a log base 3?
A big old 3.
A big old 3 on both sides, and that cancels out, and I end up with x equals 3 to the 4th mental mathers, or non-mental mathers. How do you do 3 to the 4th?
2, 7, 3.
3 squared is 9, 3 squared is 9, 9 times 9 is 81.
That's cool.
Right?
So 273 is 36. That should be.
Yeah.
No, 240 is there.
Just do
240. Okay. Dun 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 dun. So, let's come on back in. Now, I'm not going to go crazy on this, but let's talk about those examples that we just did. We just did every single one of them, right?
Yeah.
They would say, hey, rewrite. Oh yeah, we rewrote. We just didn't really think about it. We just factored. Rewrite and use the one-to-one property, right? Isn't that what we did, basically? They said, rewrite, move to the other side, and say, hey, one-to-one property again. Sweet. Rewrite, oh yeah, make them both with 3s. Okay, it's getting kind of tedious. Oh. Oh yeah, we used the inverse property, right? What was the word that I asked? I said, how do you undo, right? How do you undo? That's the idea of inverse. The next one, how do you undo the idea of inverse? Undo the idea of inverse, undo the idea of inverse. So what did we use on all of these? Either one-to-one properties or inverse properties. So are those helpful tools? Yeah. Is that enough?
Whoa.
Kinda. If you need a strategy for facing exponential and logarithmic equations, which might get harder, and some of those were tricky. If you need a strategy, here it is. And step number 1 is kind of important because we didn't have any really tricky ones on the page we saw. They were kind of tricky in different ways. So strategy number 1 says isolate. Get the exponential or logarithmic piece part by itself. In algebra, we would say get y by itself, and that was a strategy. As soon as you got square roots involved, it was get the square root by itself so you can square both sides and get rid of it. But now that we have exponential and logarithmic, it's get the exponential or the logarithmic by itself so we can deal with whatever's left. Number 2 says, before you do much else, see if you can use one-to-one, because if so, oh, he's so nice, he's so easy, he's so fast. Number 3 says, right row. If you can't use the one-to-one property, you gotta undo. And undo means using the inverse property. But even though all of those on the other page said the inverse property, guess what? I'm saying you undo with the inverse property or the power property. Huh? You undo with either the inverse property or the power property. Skip me one line each for logarithmic exponential. Maybe a couple. Because harder problems are coming, I have to introduce something that you're not going to like, that's going to help us face harder problems. Let me go ahead and show you guys what I just saw. Well, let's finish this page first. Alright, undo with logarithmic. If we're undoing with logarithmic, we can actually read that kind of 2 different ways. So let's go ahead and say we have, our problem is with a logarithmic, okay? So let's say we have a logarithmic somehow involved. I'm going to show you 2 different variations. Let's say we have log base a of x equals, for lack of a better, let's just say c, okay? This is an easy example. If I have log base a of x equaling c, So I have a logarithmic piece. How do I undo? Yeah, big ol' A, meaning use exponential. And what do I mean by using exponential? Make the logarithm an exponent. What you do to one side, you do to the other, and then that just quickly cancels out, and you end up with x equals a to the c. Right? I'm making it look simplistic. It can get a little trickier, but to be honest, to undo a log is nicer than the other form of what's coming. Now with exponential. What if I have an a to the x equaling a b to the, let's just do the, let's do b to the c. And let's say I can't make b into a. So we have two different bases and I can't make b match a, so I can't use the one-to-one property. They're two different numbers and I can't make it work any better. What would you do? Who are we ultimately going for? Who are we trying to solve for? We're trying to solve for x. C is just a constant, so he's okay, he's just a number. I'm going to say using logarithms, I'll say log base a, or ln. Using log base a or ln. What do I mean? There are two different approaches to this problem. If I was to put this kind of in the middle, let's just put it right there. One approach would say, hey, go ahead and just take log base a at both sides. No big deal, we've done it times before. Log base a of the a to the x and of the b to the c. Okay. If I take log base a of both sides, what happens to log base a of a to the x? It's just x, right? And I get log base a of b to the c. Did that work? Yeah. It's kind of gross. It's kind of yucky. But it works. It'd be kind of take you a few steps to put it into your calculator, etc. But it works. But I also want to show you a different variation in that you can take the exact same, not what I wanted, the exact same expression, and I want to show you just the idea that you don't have to use log base a. Because of the power property, you could actually put in any logarithm, and I like ln because I've already told you it's better for calculus kids. But how does it work if it's not log base a? Log base a of a just cancels out, no big deal. How does it work if it's an ln now?
You're gonna put an e?
Don't have to put an e. I can use the power property to say, oh hey, it's x ln of a equals ln of b to the c. And then how would I solve for x? Divide. Now I know you're like, ew, that's gross. Why'd you do that? Well, I guess you could have also just done a change of base formula, ln of b to the c over ln of a. But I'm just showing you the idea. You don't have to use log base a to undo an exponential. You can use any log. And the power property, which has the power pop down, now all of a sudden it's not stuck anymore. If the power pops down, he's not stuck in A, so I can go ahead and just move that whole part away with division and be done. Nicole?
Why did you not bring down the C?
Oh, I could have. Would have been one more step, I was being lazy. Okay. This is a general idea, kiddos. Even though I've written a lot on this page, it does not mean that's going to help you with every single problem, hence why we're taking 2 days on this, and let me show you another reason why. We only have a couple minutes left of class, right? Okay. Let me show you what else notes is comprised of. Homework help. Homework help. Homework help. Homework help. Homework help. Homework help. Oh! Are we going to get through all those homework helps today? No. Does that mean that you can't do the homework? Not necessarily. Some of you might be able to do the entire thing. However, some of the problems get tricky. So I'm just we're gonna start working, practicing today for like a minute and a half, and then Monday we'll do some more. Don't back up. Question, what can we do for letter A? Yeah, whew, 1-to-1 property. I'm not gonna exactly cross out just because that's a little illegal, but the idea is still there. You're getting rid of the e's. Okay? You could take ln of both sides, both e's disappear, either one. Then how would you solve? Get one side equals here. Yeah, right? I'm gonna add this one because I like the x squared to be positive instead of negative. Sorry. Then you would have to going quick because you guys know the factor. Okay. What would you do in the next one? Log base 2. No. First step was isolate. Isolate who? Isolate the exponentially do. How? Yeah. Get him by himself first. This is what that isolating step is for. Get 2 to the x alone, and then 3 into 42 is 14. Do I just do log base 2 of both sides? Could. You could say x is equal to log base 2 of 14. But I actually, because I'm getting ready for calculus, would say, or you could just take an ln of both sides, and what happens to the x? Then you could divide. You could say x is equal to ln of 14 over ln of 2. Question, why are these both just as correct as the other? This one has a log base 2. This one has changed the base. Anyway, it's a good introduction. We have a lot more homework out there. Thanks, practice, etc. to do on Monday. You guys have the rest of your Friday. Enjoy nutrition, enjoy your weekend. Have fun, make wise choices, happy early birthday. Tomorrow, yeah. Okay. Got it?